Hello everyone, welcome to another video. We have on the board another question about velocity and acceleration, and I read, a train is slowing down with constant deceleration, that is negative acceleration. It passes a signal at A, and after successive intervals of 40 seconds, it passes point B and C, where AB equals to 1,800 meters. So which means the distance transversed by the train from A to B is 1,800 meters. And then from B to C is 1,400 meters. So according to the question, we have that after successive intervals of 40 seconds. So which means for the first 40 seconds, the train travels a distance of 1,800 meters. That means it covers a distance of 1,800 meters. Then for the next 40 seconds rather, then it covers another distance of 1,400 meters. Now, the first task, okay, is for us to calculate how fast is the train moving when it passes A, okay, and that will be the initial or starting velocity. Then how far from A does it comes to stop? Okay, that will be the distance. So in this case, the value of the final velocity or speed will be must be equals to 0, because the question reads how far from A does it comes to a stop. All right, so our solution. So what I will do first is to set up the distance time equation, okay, for calculating velocity. Yeah. So, and in this case, the acceleration will be what? Must be negative, and it will be constant. So I'm going to write, let XAB, which is the distance transverse by the train from A to B, to be 1,800 meters. Then XBC, okay, that will be 1,400 meters. So by setting up the equation, okay, now using the equation of kinematics, one of the equations of kinematics, that is S equals initial velocity multiplied by time t. So in this case, the value of A will be negative. So this will be minus 1/2 of AT squared. All right. So when we have S to be equals to XAB, which is 1,800 meters, okay? So we have that for the first 40 seconds, okay? We're going to have 1,800 to be equals to initial velocity multiplied by 40, which is when the time is 40 seconds, okay, then minus 1/2 of the acceleration, okay, multiplied by, this will be 40, then raised to the power of 2. Okay, so I'm going to multiply this equation by 2. I'm going to multiply this equation by 2. So multiplying this by 2, this is going to be 3,600, okay, then this will be 80 VI minus, this will be 1,600 times A. Okay, so let's see how we can reduce this. So I'm going to divide this by 40. I'm going to divide the equation by 40. So dividing the equation by 40, so this will reduce to, dividing this by 40, that will be 90. So we have 90 equals to 2 VI minus 40 minus 40A. I will again divide this equation by 2. Okay, dividing this by 2, this will be 45 equals to VI, okay, minus 20a. So I'm going to call this equation 1. So that's the first equation. Okay, now for the next 40 seconds, for the next 40 seconds, okay, then we're going to have that to be, the distance will be distance traveled by the train from A to C. That will be the total distance. That will be XAB plus X subscript BC, and that will be 3,200 meters. That is because 1,800 plus 1,400, that will be 3,200 meters. Okay, all right. So we have the second equation will be 3,200 equals to, so we have VI multiplied by 80 minus 1/2 of A multiplied by 80 raised to the power of 2. Okay, so that this will be 3,200 equals to 80 VI minus, this will be 6,400, that will be 3,200. So we have 3,200A, 3,200A. All right, so we can also reduce this. Okay, so I'm going to divide by 80. So let me divide this equation by 80. Okay, divide by 80. So dividing this by 80, I'm going to get this to be 40. Okay, I'll get this to be 40. Then I'll get this to be, this will be VI, which is the initial velocity. Then this also will be 40A. Okay, so this becomes equation 2. That's equation 2. Now, what I'll do is I'm going to make VI the subject of the formula from equation 1, and I'll do the same thing with equation 2. So from equation 1, okay, we know that the initial velocity will be 45 plus 20a. Okay, then also from equation 2, we have that the initial velocity will be 40 plus 40a. Okay, so this is where we can equate the two equations. Okay, because remember, the initial velocity remains constant in this case. So that means that we're going to have 45 plus 20a to be equals to 40 plus 40a. Okay, so that this will travel to the right hand side, and this will travel to the left hand side, so that this will be 45 minus 40 equals to 40a minus 20a. So this is 5. Okay, why this will be 20. So dividing both sides by 20, okay, we're going to have the acceleration to be 1/4. That will be 0.25 meters per second squared. So this is the acceleration. Okay, now let's calculate how fast is the train moving when it passes A. So I can use one of these equations. Okay, so let me just substitute the value of A. Okay, substituting the value of A into, so we have one of the equations to be initial velocity equals to 45 plus 20 what? A. So that the initial velocity will be equals to 45 plus, now 20 multiplied by 1/4, because 0.25 is 1/4. So 20 divided by 4, this is 5. So this will be VI equals to 45 plus 5. So the initial speed or velocity will be 50 meters per second. So this, which means so how fast is the train moving when it passes A? Okay, the train is moving at a speed of 50 meters per second. Okay, when it passes A, that is the initial velocity or speed. Okay, all right. Now, the second question, okay, our task here is to calculate how far from A does it come to stop. So which means now to calculate distance, how fast from A does it come to stop? So in this case, the final velocity will be equals to 0. So when the final velocity is equals to 0, so if you are using one of the equations of kinematics, which is final velocity squared equals to initial velocity squared minus 2as, because we want to calculate how far from A does it come to stop. So which means I can say that let S equals to how far, okay, from A, how far from A the train comes to stop. Okay, how far from A the train comes to stop. Let's not forget that the final speed of velocity in this case will be equals to 0. Okay, now I like to use final speed or final velocity because I know that speed and velocity have the same unit of measurement. Okay, all right. So, but in this context, we're not so in this context I can call it speed or velocity. All right, so in this case, so let S equals how far from A, okay, how far from A, okay, the train comes to stop. Okay, so that is the distance. So the distance, from A, okay, from A, as the train passes the signal at A, it takes the train to come to stop. So I just want to clarify something here. Okay, so in this case, we have the final velocity squared equals to initial velocity squared minus 2as. So this is 0. So this will be initial velocity squared, which is this value we calculated, this value, then minus 2as, so that s can be equals to the initial velocity squared divided by the acceleration, so that this will be s equals to the value of vi. Let's not forget that initial velocity is 50 meters per second, which is the one we calculated in this case. How fast is the train moving when it passes A? So we have S to be equals to 50 raised to the power of 2 divided by 2 times 0.25, which is 1 over 4, and that will be 1 half. Okay, so that this will be 2500. So we have S equals to 2500, then multiply by 2, because 2 times 1 over 4, that will be 1 over 2. So that will be 2 multiplied by 2500. So this is going to be 5,000 meters. So for the first one, okay, for question A is equals to the velocity, okay, the initial velocity is 50 meters per second. Then for B, okay, how far from A does it come to stop? Okay, to stop, that is 5,000 meters. And here is our answer to the question. The noblest pleasure is the joy of understanding. Bye bye.